Welcome back, students, to another lesson. And for today's lesson, we'll be looking at Thevenin, right? Theorem. So there are a couple of questions that I'm going to do, and hopefully you would understand how to solve for Thevenin. Okay. So the first question is, we have 120 volts, right, with 11 ohms. Connected in parallel is 22 ohms, and then we have 8, and then we have 16, and then 5, and this will be point A and point B. Okay, so they want us to find the current at 5. So the question is the current at 5. That is the question, right? So they want to know what the current at 5 is. So to solve Thevenin, there are 3 steps to solving Thevenin, right? So step 1, your load resistor. So what is your load resistor? So your RL is going to be 5 ohms, which is this 5 ohms over there, right? Then step 2 is going to be you have to find your Thevenin resistor, which is RTH. So now to find your Thevenin resistor, you are going to redraw the diagram. So it's going to be, so the steps are, you're going to remove the load resistor, and you're going to remove the source, and you're going to start from left to the right. Okay, so now let's copy this one, copy, paste. So now we're going to follow step number 2. So step number 2 says we're going to remove the source, the load resistor. Then you're going to remove the source, and then you're going to start from the left and you're going to move to the right. So now you have to find the total resistors for the new diagram, right? For the new diagram. So the total resistor for this diagram is going to be, so we have 11 is in parallel with 22, and then it's in series with 8, and then 16. So for exam purposes, you could draw it 3 or 4 times. Okay, you could redraw the same diagram as much times as you need or like. So now we are going to find the resistor, right? So it's going to be 1 over 11 plus 1 over 22 to the power of negative 1, and that gives us an answer of 15,33 ohms. So we can erase this, and we're going to put 15,33, and then we're going to add sorry guys, this is a 10 here, that's a 10. So now so the resistor here is 10 plus 8, right? So okay, so as you can see, 11 and 22, these two are parallel from each other, but they are in series with the 8. Therefore we add resistors in series, right? And then we get 15. So now we can get our R total, R Thevenin, which is equal to 1 over 15,33 plus 1 over 10 to the minus 1, and that gives us an answer of 6,052 ohms. So now we have found our Thevenin resistor, which is 6,052 ohms. So now for the final step, step number 3, you will need to find the Thevenin voltage. So you would find Thevenin voltage, which is VTH, right? And then this will be the steps is you're going to remove the load resistor, you are going to remove the source, and then you're going to start from right to the left. So over here we started from the left to the right, and then now we're going to start from the right to the left. So let's copy this one here, copy again. So now you're going to remove the source, the load resistor I mean, and you're going to remove the source, and this is what you'll be left with, right? So you can redraw this if you like. So now we're going to redraw this. So the rule says, okay, remove this, the load resistor, remove the source. Now start from right to left. So we're going to start from right, gonna go to the left, okay. So let's start with the finding the resistor. So we're going to have we can add these two, so it's going to be 18, right? And then we see 22 and 11. So that's going to be in series, right? So 22 and 18 is in parallel, and then 11 is in series. So we're going to add in parallel, which is going to be 1 over 22 plus 1 over 18 to the power of negative 1, and that gives us an answer of 9,9 ohms, right? So now we have we are looking for the Thevenin voltage, right? So we have 11 and we have 9,9. So let's put this point C and D, right? So now the voltage across here is going to be our Thevenin voltage, because we know that voltage in parallel are equal, right? So the voltage in parallel is equal, so we need to find the voltage over here, right? So now our total resistor, we're going to use the voltage divider rule, right? So you could remove this one that says remove the source, right? Because we're going to now need the source of 210, right? So now we're going to use the voltage at 9.9 is equal to the total voltage multiplied by the voltage at 9.9 over the sum of the voltage, right? No, sorry, the resistor at 9.9 over the sum of the resistors. So then you have 210 multiplied by 9.9 ohms over 11 ohms plus 9.9 ohms. So that there gives us a voltage of 99.47 volts. So the voltage at 9.9. But we are not done, right? So this here is actually incorrect. We are not done, because you can see that you have 8 ohms which is connected to the 10 and this one, right? So we need to find the voltage over here, which is going to give us the voltage in parallel is equal to the voltage in parallel, right? So now we are going to solve for this one by finding the current. No, we have to find the current, right? So now we have to do is we have to find we need to find the voltage at 10, right? Okay, so remember I said that there is a 10, so there's a 10, so this 18, right? So the voltage here at 18 is equal to 99 comma 47, right, volts. So what we're going to do now is we are going to, because there's an 8 that needs to be accounted for, so we're going to find the current at that position. So we have 8 and 10, right? And we have a voltage of 99.47. So what we want to do is we want to find the voltage at 10. So the voltage at 10 would equal to the voltage in parallel, which would equal to the Thevenin voltage. Okay, so now we are going to use the current to the voltage divider, which is equal to the voltage at 10 is equal to the total voltage multiplied by the voltage at 10 over the the resistor at 10 multiplied by the sum of the resistors, right? So we have 99.47 multiplied by 10 over 8 plus 10, and that gives us an answer of, let me just double check that quickly, 99.47 multiplied by fractions 10 over So we get an answer of 55,261 volts, right? So that there is your Thevenin voltage. So now when you're solving for Thevenin, you're going to have to do something for me, right? And this is where you have to, this is the only way where you can get your marks for this chapter. So to get the marks that you deserve for the chapter, you need to draw Thevenin circuit. So if you do not draw this, you will not get the marks. So you need to draw Thevenin circuit. So you know that Thevenin is a series circuit. And Norton is a parallel circuit. So let me just copy the voltage down quickly. Copy, paste. So now you're going to draw your Thevenin circuit, VTH, RTH, and your load resistor, and this is 55,26. This one is equal to 6,052, and then your load resistor is 5 ohms. So the question was the current at 5. So the current at 5 is equal to the voltage over the resistor, which is 55.26 over 6,052 plus 5. So then your answer should be 6.02052 plus 5. amps. So now let's do another question. But for this question, we are going to look at the amps. So we got 48 amps, which is connected with a 12 ohm resistor connected to 6, 9, and then 10. So the 10 is our, wait, before we start, let me just write it out. So they want us to find I10. So we're going to start step by step. So step 1 is load resistor, right? So our load resistor is going to be 10 ohms. So that is our 10 ohms for your load resistor. Then step 2, your Thevenin resistor, right? Resistor RTH. So we're going to find that by copying this one, right? Copy, going to paste it here. So I hope you guys haven't forgotten the rules. The rules are basically simple. You're going to remove the load, you're going to remove the source, and you're going to work from the left to the right, from the left to the right. So you're going to have so your Thevenin resistor is going to be 1 over 9 plus 6 plus 6 is 12 plus 12 is 24, so 1 over 24 to the minus 1, and your Thevenin resistor is going to give you an answer of 6,545 ohms. So this is 6,545 ohms. So now we are going to go to step 3, which is to find your Thevenin voltage. So you're going to find your Thevenin voltage, which is your VTH. Alright, so what you're going to do is you're going to copy and you're going to paste it here. So I hope you guys will remember the rules. The rules basically simple. You're going to remove the load resistor, you're going to remove the current, and you're going to start from right to the left. You're going to move from right to the left. Alright, so your resistor is going to be 12, and then 12 is going to be parallel with the 9s, right? So it's going to be 1 over 12 plus 1 over 9 plus 12 is going to be 21 to the minus 1. Is going to give you an answer of, let me just check the answer, 1 over 12 plus 1 over 21 to the power of minus 1 gives you an answer of 7,636, right? 6 ohms. So that is what you would do if you were given the voltage, but for this case you are given the current, so you're going to use the current divider rule, right? So the current divider rule is the current at, so let's do this, we have 48 amps, and then we have 12, and then we have 21. So you're going to want to find the current at this position. So previously we saw from this example that I did, we found the voltage, right? So now for current, because current is given, we are going to look for the current at this position, right? So the current at 21 is equal to the total current multiplied by the resistor parallel over sum of the resistors, right? So that's going to be 48 multiplied by parallel to 21 is 12 over 12 plus 21. So that gives us an answer of 17,4454. Let me just double check that. 48 multiplied by 12 over 12 plus 21, 17.454 amps, right? But remember, we kind of added everything here, right? remember for this one, for voltage, for volt sorry for voltage here, we added the 10 and the 8, right? So now we are going to also remove this these values, right? So we have 6 9 6. We have a current here of 17,454, and we want to find the voltage at 9, which equals to the Thevenin voltage, right? Because we know the voltage at parallel is equal. So therefore, we'll circle this one in blue also. That one circled in blue. So now the voltage at 9 is going to equal to I times R, which is equal to the Thevenin voltage, which is equal to 17,454 multiplied by 9 gives us an answer of 17.454 multiplied by 9 gives us an answer of, so V Thevenin is equal to 157.086 volts, right? 157.086. So 157,086, and then we're going to copy this, copy, so remember guys, if you want your marks, you have to draw the, so if you want your marks, you have to draw the Thevenin circuit. So you have to draw the Thevenin circuit, which is Thevenin voltage, Thevenin resistor, and then your load resistor over there. So now we know that this is 157,086. This one is 6,545, and this one is 10. Okay, so now we have to find, we are trying to look for the current at 10, right? So now the current at 10, if I'm not mistaken, the voltage, the current in series is equal, right? Current in series is equal. So the current at 10 is going to be the voltage over the resistor, right? Total voltage over total resistor, which is 157,086 over 10 plus 6,545, and that gives us an answer of 157.086 over 10 plus 6.545, and that gives us an answer of 9,49 amps. So that's how you do these problems with Thevenin and Thevenin circuits. This is how you solve Thevenin circuits. Thank you for watching this video, and hopefully I would see you in the next class.